Hello and welcome to a special report with your host, me, Vincent. Today we're going to talk about natural disasters. Actually, we're going to talk about one natural disaster. There are several kinds. Most of us are familiar with are earthquakes, volcanoes, hurricanes, and tornadoes. Earthquakes, like most natural disasters, cause major damage. They happen when the ground shuffles and anything that's on the ground will move too, including buildings. Volcanoes are a type of natural disaster too. These photos make us think that they are merely cool, but when volcanoes erupt near people, they leave a path of fire, ash, and destruction. Next, we have hurricanes. Hurricanes are storms that start on the open ocean and don't do much, but once they make it to land, hurricane winds are so strong that they can move cars and blow over trees. Flooding occurs while the wind sweeps the ocean over the land. The tornadoes are land-based windstorm disasters. A funnel of wind starts swirling around, and trees, cars, helicopters, sometimes even cows can be sucked into it. What I want to tell you more about today is a different type of natural disaster. But in order to do that, we need some new scenery. Imagine you are on a beach, relaxing in the hot sun, enjoying the warm breeze, and then the water starts to recede away from the coastline. Within seconds, a giant wave is headed straight for you. That's called a tsunami. A tsunami wave can be as small as 3 feet and as big as 100 feet. When they're that big, they cause a lot of destruction. But let's see where they come from. The Earth is divided into different layers. These layers have different properties. We live on the crust. It's the land and water that make up the different parts of the Earth. Where the crust meets the mantle, the layer below the crust, there are tectonic plates that cover the entirety of the planet. There are 7 plates that cover the Earth. Because these plates sit on a partially molten layer, they can move or shift. Most movement occurs where 2 plates meet, also known as a fault line. The movement of these gigantic plates causes everything above and in the surrounding area to move as well. These plates can move by sliding past each other, moving towards each other, or moving away from each other. This movement is where earthquakes come from. Since the movement starts below the Earth's surface, the amount of damage done depends on how intense the movement was. Small movements can't be felt by people. Large movements, however, reach the crust and can not only be felt, but they rip apart the Earth and anything on it gets swallowed. And if you remember, like I said before, buildings, bridges, sidewalks, and streets were not built to move and shake. Okay, so by now, you're probably wondering why I'm telling you so much about earthquakes when I'm supposed to be telling you about tsunamis. Well, earthquakes happen to be on the bottom of the ocean too. Fault lines, remember those are where tectonic plates meet, can be located anywhere, and by anywhere, I mean the middle of the ocean. The seafloor can move towards, away, or slide past itself. The changes in the ocean floor produce energy that radiates up and out the point of change. The movement of the ocean floor causes the water to move. It can raise the level or height of the sea. As the water falls back down, waves are formed. If the movement of the ocean floor is large, then the energy pushes up the water enough to cause waves to start radiating out. These waves are tsunamis. To be fair, there are other things that can cause a tsunami. Underwater landslides, underwater volcanoes erupting, and meteorites crashing into the sea. Pretty much any large-scale disruption of the seafloor that produces energy and can cause a tsunami. All that said, earthquakes cause 90% of them. Okay, so back to the tsunamis themselves. In the middle of the deep ocean may only get to 3 feet high. You've probably seen waves almost that big at the beach, and those size tsunamis do nothing more than send waves that ships would barely feel. However, if tsunami starts close to land and it's powerful enough, it can get much bigger. As a matter of fact, a tsunami wave moves closer to land, it gets bigger because the water gets shallower and shallower until it reaches the shore. There have been tsunami waves measured at 100 feet high and 500 miles per hour. Yep, you heard that right. 500 miles per hour. That's as fast as a jet plane. This brings me to the sad part of this lesson. When tsunami waves that are big and moving that fast reach land where people live, it's pretty devastating. What do you think happens to the boats in the water, to the houses and other buildings, to the animals and people? I think you can guess. The destruction caused by a tsunami can also be measured by the amount of loss calculated by money to repair it and by loss of life. If tons of buildings get ruined and it costs millions of dollars to fix, that's bad. It's time we change scenery again. I'm here in a tsunami lab where scientists study tsunami waves. If an earthquake is indeed the culprit, earthquakes are measured using a seismograph. Think of it like this. Say you were holding a pen trying to write your name and then got a roller coaster. I'm pretty sure your handwriting would be wacky. Well, that's kind of how a seismograph works. The more intense the earthquake is, the more scribbles on a paper. When a seismograph starts getting all excited and scribbles its head off, an earthquake is nearby. And if that earthquake is underwater, there's a chance for a tsunami. So you're asking, how can we help to mitigate or reduce the damage caused by a wave? Warning systems do exist. Hopefully, more and more research will be done and better warning systems will be invented. Well, that's all for now. Hope you learned a lot, and take care. Yeet!